we have presented in the last presentation. So we did a model in COMSOL to see how this diffusion is working. There is a module in COMSOL which is called TDS, and using TDS and varying the different properties like density and amplitude of different skin layers, we basically examined how this diffusion was taking place. So, but today what I'm going to talk most about is basically the experimentation part and the device proposal. So we did by two methods. Firstly, the first method that we used was direct extrusion printing. So we have a bioprinter in our lab. So here basically we use CAD array. Firstly, we design this array in CAD. See the dimensions, these are quite large dimensions because we are limited by the current nozzle availability. But the same, this is kind of a proof of concept, so it can be extended if you have a very small nozzle, as well as like we use pneumatic pump here. If you have a like high capacity compressor, you can also print in this same fashion quite ultra fine and micron size structures. And this is what we have used as the bioink. So we use a biocompatible material. Primarily you have nano crystalline cellulose, which is providing this mechanical support, as well as you are using a sodium alginate base, so which is also biocompatible. So this is just it's going to take time, but I'm just going to show you that this is how this bioprinter is essentially printing this by extrusion. And the parameters that we have varied in our experimentation are firstly the nozzle pressure. Since this is a pneumatic bioprinter, we are varying the nozzle printer and we are getting different kinds of results. I think in sample 1, 2 and 3, these are following in this order. So the optimal kind of a sample that we have gotten is in sample 2, wherein the nozzle pressure was 30 kPa, and because 5 millimeters per second is the extrusion speed. So this is kind of the final sample that we have gotten. And the next thing that we have followed here is like direct printing is one method. We have also tried replica molding here. So in replica molding, primarily we need to create a master mold. So master mold, we have a 3D printer which is basically using a polylactic acid plastic material to basically it melts it and then it prints layer by layer. And as usual, we have to design this in the CAD, and we have used the same size in CAD here. And this is kind of the final mold that we have created. And there basically we have to now deposit a certain biocompatible material. So this we have basically obtained the primary schematic from literature, but we have tried optimizing the various parameters. So essentially what we are doing is we are developing a hydrogel. Now this hydrogel is composed of two things. One is polyvinyl alcohol, and secondly it is basically forming hydrogen bonds with carboxymethyl cellulose. So this is the kind of the general schematic that basically shows what kind of experiments are conducted in order to develop this solution, and upon curing it, we got in two samples. First sample is basically like giving us a rather hard structure, but like it's not flexible. So in order to increase the flexibility, what we did was we again tinkered with the different amounts of EVA and CMC, as well as the DI water that we are doing. We are inputting in the system, and thereby the final material that we got, it had this kind of like, it had reduced durability, but it had flexibility. Now this again we have to optimize the solution, but these are the results which we have obtained from the replica model. Now as conclusion, so these are the steps which we have followed for like developing a proof of concept of the device. We have done a dry lab simulation here. In dry lab simulation, we have essentially seen that if such a material is constructed, how it diffuses out into the skin. Then we have done basically the two kinds of fabrication, that these two methods of fabrication are possible. Like either you can directly print it if you have a bioprinter and you know how to adjust the parameters. And the second thing is that we have done replica molding here. Replica molding also we can do. We can make a master mold, we can pour the solution, again cure it, and then take out the material. Now, in order to like essentially develop this into a complete device from a prototype, we need to do several other tests. Firstly, we need to do the biocompatibility test extensively, or like we need to do trials. We actually need to perform like mechanical tests and everything. And with that, basically, I conclude, and I must thank the people from this soft materials and micro nano fluidics lab, the DB lab, because I believe without their help, I wouldn't have been able to come up. Like they have really helped me at every stage to basically understand how to do the experiments and everything. So I actually owe my gratitude to them. So with that, I conclude my presentation. And if you have any questions, I can take them. Or otherwise, even if you want to ask me any questions later, you can contact me via email. Thank you very much.
Thank you.